Good afternoon, everyone. Our lesson for today is about relation and function. Part 1, of course, with me, Mama Rita. Okay, class. What is a relation? A relation is an association between the first set called the domain and of the relation of the second set called the range of the relation, such that to any element of the domain, there corresponds at least one element of range. Okay, class, let's go to representation of relations. Okay, class, so we have an example here, the ordered pairs. So we have four ordered pairs, 1 comma 2, 2 comma 6, 3 comma negative 2, and 4 comma negative 6. We are going to find the value of the range. The range are the x coordinates. So let us list down all x coordinates, which are 1, 2, 3, and 4. As you can see, the x coordinates are not repeated. While the range, we have the y coordinates, which are negative 6, negative 2, 2, and 6. So another set of ordered pairs. So we have 4 comma 6, 5 comma negative 7, and 7 comma 9. So we are going to find the domain or the x coordinates. So we have 4, 5, and 7. While the range or the y coordinates, we have negative 7, 6, and 9. Okay, we have here the table of values for the x and the y's. For the x, we have 0, 1, 2, 3. And for the y's, we have 1, 3, 5, and 7. So the domain here are a set of elements of 0, 1, 2, 3. The range are 1, 3, 5, 7. Okay, in mapping, so as you can see, one domain versus one range. Okay, no such element are repeated, meaning to say the domain are 1, 3, 6, 10. It's not repeated to the range such that 2, 5, 9, and 12. Now, let's go to graphical representation. At the right is an example of graphical representation of a relation. It illustrates the relationship of the values of the x and the y. Equation. The value of y is 2 less than the value of x. So in other words, this can be described by the equation y is equal to x minus 2. Let's go now to function. So what is a function? Function is a relation in which no two pairs in a set of ordered pairs have the same first element. Okay, now class, let us focus on the x coordinate when given a relation. If the set of ordered pair has different x coordinates, it is a function. If the set of ordered pair has the same x coordinate, it is not a function. Y coordinates have no bearing in determining a function. Okay, we have here an ordered pair. So we have a set of four elements. Okay, so that is 1 comma 2, 3 comma 6, 5 comma 2, and 7 comma negative 6. So we have here the table of values. As you can see, the x's or the domain are 0, 1, 2, 3. So there is no repeating values. And the y coordinate is 1, 3, 5, 7. That is the range. Okay. So the rule of equation here is x minus 2. Y is equal to x minus 2. Okay, now class, we have here an example of function by mapping diagram. In figure number 1, as you can see by the domain and the range, there is no such number repeated. So that is a function. While in the second figure, we have the domain which is negative 1 and 1 repeated by the number of range 5. So it does not affect any repeated value of range as long as the domain is not repeated. So that is a function. Next is the figure number 3, having the domain of 2 and 3, which is the same range of 7. So this is a function because no repeated x value is used. Let us have now the relation and function part 2. Okay, for part 2, we have here a Venn diagram which has a characteristic of relations and function. Let us have a review for the relation. A relation is an association between the first set called the domain of the relation and the second set called the range of the relation such that to any element of the domain there corresponds at least one element of range. Okay, so while in function, a function is a relation in which no two pairs of set of ordered pair have the same first element, which is the x coordinate. Okay, here class, let us have an exercises. So tell whether the given represent a function or Merle relation. So let's have number 1. Okay, we have the set of elements having a coordinate of negative 3, 4, negative 2, 4, negative 1, negative 1, and 3, negative 1. So what do you think is that? A function or a relation? That is nice. So that is a function. Whether the 4 here of y's is repeated but the domain are not, it is a function. Okay? For number 2, let us have the three elements. Set of coordinates are 1 comma 3, 1 comma 5, 2 comma 5. What do you think is that? A function or a mere relation? That is nice. You got it. It's a mere relation. Why? So look for the x coordinates. It is repeated. So it's not a function but merely relation. Next, let's have here a table for number 3. Look for the x or the domain and the y is the range. Okay, the domain are negative 3, negative 1, 0, 2, and 3. While in the y-axis or the range, we have 0, negative 1, 0, negative 2, 4. Is it a function or merely a relation? That is nice. It's a function. Why? There's no repeated x or x coordinate. Let's have another example of table, x and y. So we have here the coordinate of x, -2, -2, -1, 1, 2. So we have the x coordinate, and while the y coordinates, we have -1, 1, 0, 0, 1. So what do you think is that um, set of elements? Is it a function or merely a relation? Very good. So that is merely a relation. Why? Look at the x-axis. -2 is repeated. Let's have number 5. Okay, look for the mapping. Look at the domain. We have 2 and 8. It is repeated to the range of 21 and 25. Okay, so what is that set of elements? Is it a function or merely relation? Correct! So that is merely relation. Why? Look at the x or the domain. It is repeated in two range. So that is not a function, but merely relation. Okay, next. For the last one. Okay, look at the picture or the mapping. We have the domain 5, 10, and 50. It is the range of 5 and 15 is equal to 105, while 10 is 110. What do you think is that mapping? Is that a function or merely relation? That is correct. So that is a function. Okay. Did you understand, class? Okay, always remember, class, all functions are relations, but not all relations are functions. Look for the X. So we have here another example or additional information, which is correspondence. So we have one-to-one, which is no repeated value of X and Y. We have many to one, which is uh, some of the domain have one range, okay, and some are not. How about many to many? One to many, rather. One to many, so that is one domain together with all ranges, okay? So here, class, we have a vertical line test. So a graph of a relation is a function if any vertical line drawn passing through the graph intersect at exactly one point. Okay, here, class, let us study these four graphs. So let us have a test of vertical line. So we will draw vertically if it is passes through in exactly one points of that relation, meaning to say that is a function. So let's have this one. So if we have an intersecting line, so that is now a function. So we have intersection. So this is a function. Next, for number 2, we have a circle inside the Cartesian plane. So if we do the vertical lines, we will have two intersection. So meaning to say that is not a function, but merely relation. Next, number 3, we have a parabola. So if we do here vertical lines and it has an exactly one points of intersection. So meaning to say that is a function. Okay? While in number 4, if we drew if we draw a vertical line, so we have here two intersections. So meaning to say this is a merely relation. Okay? So we have here horizontal line and the vertical line, class. So the horizontal line represents a function. It can be described by the equation y is equal to the constant, or where c is the constant. Okay? Uh, it is called the constant function. However, a vertical line which can be described by the equation as x is equal to c or is equal to constant. It is a Merle relation. Okay? So here in the graph, first figure, horizontal line is a function because this is y is equal to -2. While in vertical lines, it is merely relation, which is x is equal to -4. Okay, a relation can be represented by a rule of equation in two variables. So we have an equation y is equal to 3x plus 5. If x is equal to 1, so y is equal to 8. Then if x is equal to 2, y is equal to 11. Then if x is equal to 3, then y is equal to 14. Then if x is equal to -1, then y is equal to 2. So as you can see in the table, we have the ordered pair, which is 1, 8, 2, 11, 3, 14, and -1, 2. Meaning to say, or therefore, the rule is a function. Okay, class, a relation can be represented by a rule or equation in two variables. So we have number 2 example, x is equal to y squared. Meaning to say, if x is equal to 0, so we will get the square root or the positive and the negative square root of 0, that is 0. So if x is equal to 1, so to get the value of y square, that is positive and negative square root of 1, so which is equal to positive 1 and -1. While if x is equal to 4, the square root of 4 is positive and negative 2. Meaning to say, the ordered pairs are 0, 0, which is the origin, then 1, 1, 1, -1, and then 4, 2, then 4, -2. As you can see, the value of x is repeated. So it is merely, so the rule is mere relation. The first element is repeated. Okay, class, remember, an equation represents a function if no exponent of y is an even number. Okay, class, the independent and dependent variables. A variable is considered the independent variable because any value could be assigned to it. However, the value y of variable y is the dependent variable because its value depends on the value of x. Here now, class, let us classify in each situation the dependent and the independent variables. Take note. Okay, the independent variables are the x, and the dependent variables are the y's. So we have here the situation, time of work and salary. So what do you think is the dependent and the independent variable? Okay, very good. Time of work is the independent variable because it's depend on the salary. If you work more than 8 hours a day, so your salary getting higher. So the dependent variables are the Y, which is the salary. Next here, cell phone bill and number of calls. Which one is the independent and the dependent variables? Nice one. So here, the independent variables is the number of calls. Why? If you call 24 hours a day, so the dependent variables will, your cell phone bill will get higher. If your calls are minimal, so the cell phone bill will get low. Okay? Next, the distance travel and the amount of gas in a car. Which one is the independent variable and the dependent variable? Correct. So the amount of gas is depends upon the distance of travel. Okay, if you travel longer, if you travel from Manila to province, so your amount of gas will depend on the distance travel. Okay, so thank you very much for listening. Hope you learned something for our lesson for today. See you again next time in an online class.